Good afternoon, everyone. Thank you for joining the webinar. My name is William, and I'm an application engineer for GoEngineer. Today, I'm going to be talking about a cool project that I worked on recently. And I'm a car guy, so every time I'm presented with an automotive project like this, I have a lot of fun with it. So a little background information on the project. We have a customer that's currently in the process of restoring a 1986 Buick Riviera. And this vehicle is very important to our customer because it's been in the family for a long time. So they're really looking to fully restore it at some point. So because this is an older vehicle, they're starting to realize that a lot of parts are very difficult to find or reproduce. And if they are able to find some of these parts online, a lot of times they're already broken or warped. One such part is the coach light. And it's a pretty important part because, as you can tell, it has a Riviera logo on it and it also lights up at night. So it's a very important piece. This customer heard that GoEngineer provides 3D scanning, reverse engineering, and 3D printing services. So they reached out to us and asked if this project was a good fit. And I said, yes, we do stuff like this all the time. So I asked the customer to go ahead and ship this to me. And it's actually an assembly of 3 parts. So the plan was to 3D scan each of these individually, reverse engineer them, and ultimately 3D print them. Now, I used a variety of our GoEngineer products to get this to work. For 3D scanning, I used our Creaform HandyScan Black Elite. For reverse engineering, I used Geomagic Design X. To make CAD modifications and drawings, I used Solidworks. And finally, to 3D print the parts, I used our Stratasys F370 and our J850. However, today I'm going to be focusing on the Geomagic Design X portion of the project. So after I 3D scanned the parts, I brought the data into Geomagic Design X. And this is a pretty unique software because it has reverse engineering capabilities, but also CAD capabilities as well. So it makes it great for this application. One of the first things you'll notice about 3D scan data is that it's usually floating in space. If I turn on my standard planes, you'll see that it's currently floating in space. So the first thing I'm going to do is align this to the origin. So in order to do so, I'm going to create a plane for the bottom of the part. So I'll use my Smart Select tool, and I'm going to click on the bottom of the part, trying to grab just the data on the bottom, like I did here. And I can click on the plane tool, and the software has this feature called Remove Outlier. So what this does is it'll discard any points that don't give me a great plane. So I'll hit the check mark. That looks good. Now, with a good alignment, you need to get rid of 3 degrees of freedom. So the next thing I'm going to do is I'm going to go back to the plane tool, and I'm going to orient this something like this. And the reason I'm going to do this is I want to change the method to draw line. And the reason I do this is this plane is just going to be used as a guide. So I'm actually going to create a mirror plane, but this initial plane just kind of tells the software kind of where you want that plane. So I'll hit the check mark. And then after I do that, I'm going to unclick where it says visible only. And I'm going to tell the software that I want to grab all of the points on the mesh. And I also have that initial plane selected as well. And this time when I go to the plane tool, it says mirror. So the software automatically knows what I want to do. So I just eyeballed that plane number 2. But as soon as I hit preview, you'll see that the software is actually going to calculate a plane. And you can see that, my plane was off, but the software actually calculated that mirror plane using points and my plane as a guide only. So I'll hit the check mark. That one's done. And the next one I'm going to create is going to go in the opposite direction, but I'm going to do the same exact thing. I'll go to the plane tool, draw a line, and this time I'm going to draw it here. And I purposely make it skewed like this so that you can see that the software makes a calculated plane just using mine as a guide. So I'll hit the check mark, and once again that's off, and I will select every point in the mesh, and once again the software is going to do a calculation to give me a mirror plane. So I'll hit the preview button once more, and as you can see, my plane was off, but the software did a calculation of all the points and it gave me a great plane. So I'll hit the check mark. And that essentially gives me 3 degrees of freedom. And if I turn them on, you'll see that that's how I want to align this part to the origin. So the next step is I'm going to go into interactive alignment, hit the next stage, and the software gives us a split screen here so you can select entities on the left and you can see the preview of what you're doing on the right. So in other videos, I show customers how to do an XYZ alignment. This time I'm going to do a 3-2-1 alignment. And what it's asking for is plane, vector, and position. So basically plane, line, and point. I don't have a plane, line, and point, but I do have 3 planes. One thing to remember about Design X is that this translates to front, top, and right. So plane being front, vector being top, and position being right. So I want plane 1 to be my front, so I'll click on that. I want plane 3 to be my top, so I'll select that. And I want plane 5 to be my right. And as you can see here, I have a preview of the alignment. And if I want to flip any of the axes, I can just click this button here and it'll flip. And this is exactly how I want the origin, so I'll hit the check mark. Okay, so these planes that I used for reference are now floating in space. So they're basically irrelevant now. And I can just go into the feature tree here and delete them. And you'll see in a second why they're irrelevant, because when I turn on front, top, and right now, the part moved. So I essentially used those planes as a guide and the software moved the mesh for me according to my reference geometry. So this part is now aligned to the origin. And you can use any of these standard planes to check your work. And as you can see, this is now aligned to the origin. Now I can show you the steps I took to reverse engineer this part. One of the first things I always do is I create a copy of the original mesh. And the reason I do this is just in case I make some modifications to the copy, I can always refer back to the original if I have to. So I'll go ahead and hide the original, and I will also hide the front, top, and right planes. The next thing I did was I created a region group. So regions are very, very important in this software. They help you do a lot of different things. In this case, these regions are going to help me specify the heights for my extrusions. For example, if you hover over these regions, the software says that's a plane, there's a plane there, and then there's also a plane here. So these regions help us either make measurements or create extrusions. So let's take a look at the cross sections. My first cross section is for the outside base of the part. So in this software, cross sections are called mesh sketches. So if I go to the setup, I'll show you how they're created. The software has you pick a base plane, in this case the front plane, and you intersect the mesh and you specify a distance of where you want that cross section. The unique thing about Design X is here's my cross section, but it'll actually project it to your base plane. So that makes things easy to make extrusions later. One thing to note about this particular extrusion is there is some draft. So the software has this button right here that allows you to estimate draft even at the cross-section level. So it's pretty helpful in this case. Okay, so I'll go ahead and exit out of this and show you my sketch. Now I do have this complete. If I hide the mesh, I've already created this sketch, but I want to show you how easy it is to do this using Design X. Now in other software you have to manually trace over stuff. Here in Design X we have a lot of tools that make things a lot easier. So the first thing I'm going to do is create some construction lines. So I'll do one in the Y direction and I'll do another one in the X direction. Hit OK. Now the reason I did this is I actually want this part to be symmetrical. I mean, it appears to be symmetrical, but it's not perfectly symmetrical. As you know, with some of these older automotive parts, based off of the manufacturing processes of the day, some of these parts are not symmetrical. So moving forward, we would want to reverse engineer this with this part being symmetrical. So Design X has this auto sketch tool which I'm going to use, and I really only need to design a quarter of this because I'm going to mirror it twice. So all I have to do is left click here, left click there, and then I'm also going to left click here and hit the check mark. So the software is very smart, actually added tangency for me there, but I will have to do some manual work here. So obviously because there's a slot there, the auto sketch tool didn't work there, but not a problem. What I'm actually going to do is I'm going to click on this arc and then double click on this arc until the software I want this to be tangent. The next thing I'm going to do is I'm going to use this resize tool and basically extend both of those arcs. And the reason I'm going to do that is because I want to trim them together. So I'll use my trim tool here, power trim, and then now that's tangent on both of the segments. The other thing I can do is I can grab this center mark here, and just to make sure I have tangency there at the top or at the end point there, I'm going to make a vertical relationship there. And finally, I can trim that as well. Done and done. So I really only needed to draw a quarter of this, like I mentioned. We do have mirror at the sketch level, so I'll click on the mirror tool, and this will be the symmetry line first. Entities are those, check mark, and then I'll do a second one using this as the symmetry line, and then using these as the entities. Actually, let me go ahead and grab all of them. And that's how I created that outside profile. Now, I do deviate a little bit because, like I mentioned, these parts aren't perfectly symmetrical, but moving forward, we would want them to be. So that's why I did that. So I'll go ahead and hit the X. That's already done. And I want to show you how those extrusions were created. So my first extrusion you can see is right there, but you might be wondering, how did you know the height? Well, as I mentioned earlier, we use those region groups to help us do that. So if I right click on this extrusion and I turn on the mesh, you can see that I'm able to snap to that pink region. So software says 0.2715. As the reverse engineer, it's my choice to leave it as is or maybe round that up or down. That's your choice at that point. But essentially, those regions allow you to snap when you're making a extrusion and give you an accurate result. So that's what those are used for. I already have that done, so I'll hit the X, and you can see that I'm starting to create parametric features, right? So these are features that have a sketch associated to them and obviously 3D data, right? So once you do that one time, it's pretty repetitive from there. You would create cross sections for each of the sections of your part. In this case, for that outside ellipse shape, right? So I did the same thing there. I created another extrusion, and then using my region, in this case, it was going to be this orange region. I did the same exact thing. And like I said, it's very repetitive from there. You just keep going step by step. In SolidWorks, we call this the layer cake approach to design. And this is obviously a simple part, so it's not that difficult, but you can kind of see how the part starts building there. The Riviera logo was the next extrusion here. I did the same thing. I used my auto sketch tool and then used my region to specify my height for that feature. And then finally, we had that bar feature. That's also an extrusion. And as you can see there, that's how I was able to pretty much recreate the entire part. The last thing to do was to create a shell. Now, you might be wondering how I got the wall thickness for that shell. Well, if I right click on the shell feature and I say edit, this feature also has this little wand that says estimate depth from mesh. So that feature also gives you an estimate. And I clicked on it right now and it says 0.104. Now me, as I mentioned earlier, as a reverse engineer, that's my choice. I'm just going to leave it at 0.1 because I don't think that depth is 0.104. And with that said, I'm just going to hit the X there because I already have that done and I created the shell feature for the bottom. And finally, the last thing to do for this part was create the slot cuts. So if I roll forward there, I essentially created, the sketch there, and I could have created 4 separate bodies and then Boolean subtracted that, but I just did it all at the sketch level to make things easy and quick. So just like before, I used the mirror tool, and this part is essentially reverse engineered. The last thing you'd want to do is check your deviation. So I'm going to go to Accuracy Analyzer, click on Deviation for the body, and this feature allows me to check deviation. And as you can see, I am deviating a little bit in several areas, but as I mentioned earlier, some of these old automotive parts could be warped or just have wear and tear from use. But this is a great way to check your work. And this color bar here specifies our tolerance, which right now the green is at plus or minus 4/1000 of an inch, which is very, very good for a reverse engineering job. And that's essentially it for the first part. For the second part, I used a very similar reverse engineering process. I aligned the part to the origin, I created region groups to help me with my extrusions and my cuts. However, unlike SolidWorks, Design X does not have an assembly mode. So in SolidWorks, we're able to build a part in the assembly mode using other parts as a guide. Here in Design X, I can import bodies and do the same thing. So that's what I did. I brought in part number 1, and as you can see, there it is. And all I had to do was essentially just convert entities. That way I have the similar shape and everything fits nice and neat. So even though we don't have an assembly mode, I was still able to get this to work the way that I want. From there, the process was essentially the same as the previous part. I created my cross section, in this case, this outer profile here, and I got my first extrusion. Then I got another cross section. I did that outer lip. Same thing, using the regions as a guide for my heights. And essentially that was what I did, the same exact thing as I did the other part. I'm not going to go over each one step by step, but essentially there was some changes to this part that I want to point out. So these two snap fits were no longer necessary based off of the design that the customer wanted. He's going to be changing the lighting structure so it doesn't snap into the old connectors. So I didn't need to design them. In fact, it was actually easier for the customer to have just a larger hole to fit in a larger connector or wires so that he could figure out his lighting source later. But essentially, I made this change to give him more room to do that. And finally, the last part, similar process just like the other two: alignment, region groups, cross sections, extrusions, cuts. This was actually the easiest out of all three, so I got this one done fast. And at the end, I was able to get a fully reverse engineered model for this one as well. Now, reverse engineering is great. However, most of us want to be able to make changes in our native CAD software. In this case, SolidWorks. One of the most important features of Geomagic Design X is this button right here, Live Transfer to SolidWorks. This feature will transfer our entire feature history into SolidWorks where we can make changes. And as you can see, I was able to transfer everything I did in Design X into SolidWorks. This includes sketches, planes, extrusions, cuts, lofts, so on and so forth. It's as if you designed this part in SolidWorks to begin with. If you go into a sketch, you have complete access to everything. As you can see, the software even transferred the sketch relations and my center lines. So the next step here would be to fully define each of these sketches and create drawings. And I did the same exact thing for part number 2 and also part number 3. And that's essentially the end of the reverse engineering portion of the project. The next step was to 3D print the parts for our customer. For part number 1, I used our Stratasys J850 for its ability to print clear and multi-materials. Using the GrabCAD print software, I was able to print the part assembled and disassembled. With this software, I'm actually able to bring in my native SolidWorks files. And if I have multi-bodies, I can assign different colors or materials to them. For parts 2 and 3, I used our Stratasys F370 because I wanted to print these out of ABS. The OEM parts are ABS, so this was a perfect replacement for those. After I printed the parts, I wanted to take some pictures for some side-by-side comparisons. And as you can see, the 3D printed parts look great, and they actually fit together perfect. Here's an image of them assembled, and also an image of part number 1 that I printed disassembled. And the reason I did that was just in case the customer wants to paint or chrome the Riviera logo, he can still do that. However, I did ask for some pictures of the parts on the car as is, meaning no post-processing, no painting, no sanding, nothing. And as you can see, the parts look great right from the printer. And that's also why I printed a second set for him so that he could paint it or sand it or do whatever he wanted with that other set. But I think it looks great as is. And that's essentially the end of the project. If you have any questions about 3D scanning, reverse engineering, or 3D printing, please feel free to reach out. Thank you for watching. Till next time.